Level up your listening with Bose Quiet Comfort Ultra earbuds and headphones with immersive sound and world-class noise cancellation for a not-so-silent night. Visit Bose.com/Spotify to shop sound that's more than a present.
Big decisions require research. So if your teenager is considering a decision as big as joining the military, they're doing their homework. You can too, by visiting todaysmilitary.com, because their success tomorrow begins with your support today.
This is SpaceTime, Series 24, Episode 30. Coming up on SpaceTime, organic material crucial for life discovered on the asteroid Itokawa, a journey through the main asteroid belt, and some 1,200 Starlink satellites now in orbit. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Scientists have discovered water and organic material on the surface of a sample from the asteroid Itokawa. It's the first time that organic matter capable of providing the chemical precursors for the origins of life have been found on an asteroid of this type. The findings, published in the journal Scientific Reports, are based on a sample collected by the Japan Aerospace Exploration Agency's first Hayabusa mission to the asteroid Itokawa back in 2005. The single-grain sample, dubbed Amazon, was studied by scientists with the Royal Holloway University of London. It was part of a cloud of little more than dust regolith collected by the first Hayabusa spacecraft from the asteroid. Itokawa is a 330-metre wide, potentially hazardous near-Earth asteroid. It's considered to be a peanut-shaped rubble pile, consisting of little more than boulders, rubble and dust of varying sizes held together by their own combined gravity into a single body. Technically, Itokawa is what astronomers refer to as an S-type asteroid. It's a class of mainly iron and magnesium silicate meteoroids which dominate the inner part of the main asteroid belt and are also common in the central part of the belt but become rarer further out. This one migrated to the inner solar system and is part of the Apollo group of Earth-crossing asteroids. The fact that their orbits cross the orbit of Earth is what makes them a potentially hazardous future threat. The analysis shows that the sample material collected by Hayabusa 1 evolved chemically over time, preserving both primitive unheated and process heated organic matter within 10 microns, that's 1,000th of a centimetre, of each other. In other words, there was heated material right next to material that hadn't been heated. The organic matter in the grain sample that had been heated indicates that the asteroid itself had reached temperatures of over 600 degrees Celsius sometime in its past. It seems Itokawa underwent episodes of extreme heating, dehydration, and was even shattered to pieces in a catastrophic impact. However, the presence of unheated organic matter right next to the heated material means that an infall of primitive organic matter must have landed on the surface of Itokawa sometime after the asteroid had cooled down. So, the asteroid gravitationally reassembled itself from the shattered fragments, and it also soaked up water from surrounding space dust or carbon-rich meteoroids. What all this analysis shows is that S-type asteroids could be every bit as likely as a source for the chemistry of life on Earth as carbon-rich C-type asteroids, which were previously the main focus of attention. This is SpaceTime. Still to come, we take a journey through the main asteroid belt, and SpaceX has successfully launched its 20th Starlink mission, carrying another 60 of the telecommunications satellites into orbit. That means there are now over 1,200 Starlink satellites circling the Earth. All that and much more still to come on SpaceTime.
Level up your listening with Bose Quiet Comfort Ultra earbuds and headphones with immersive sound and world-class noise cancellation for a not-so-silent night. Visit Bose.com/Spotify to shop sound that's more than a present.
The main asteroid belt between Mars and Jupiter is a torus-shaped region occupied by hundreds of thousands of asteroids, meteoroids and rocky debris ranging in size from the 950-kilometre wide dwarf planet Ceres all the way down to tiny grains of dust. The total mass of the asteroid belt is just 4% that of the Earth's moon, with around half of that contained in the four largest asteroids, Ceres, Vesta, Pallas and Hygiene. The material in the main belt is extremely thinly distributed, but occasional collisions between bodies do occur, resulting in the generation of families of asteroids whose members all have similar orbital characteristics and compositions. Astronomers speculate that the asteroid belt formed from the primordial solar nebula as a group of planetesimals between Mars and Jupiter. Planetesimals are the precursors of protoplanets, which themselves eventually grow up to be planets. However, gravitational perturbations from Jupiter imbued the planetesimals with too much orbital energy for them to be able to accrete together to form protoplanets. Collisions became far too violent, and so instead of fusing together, the planetesimals and any protoplanets that looked like they were about to form simply shattered. Now, as a result of this, some 99.9% of the asteroid belt's original mass was lost during the first 100 million years of the solar system's history. As Jupiter and Saturn migrated inwards, some of these fragments would have been flung into the outer solar system. Then later, as Jupiter and Saturn migrated back out again, more of this debris would have been flung inwards to the inner solar system, a lot of it impacting the inner planets, leading to an event called the Late Heavy Bombardment about 3.9 billion years ago. Even today, the orbits of asteroids in the main belt continue to be appreciably perturbed whenever their period of revolution around the Sun forms an orbital resonance with Jupiter. Individual asteroids within the main asteroid belt are categorized by their spectra, with most falling into one of three basic groups: C-type carbonaceous asteroids, the S-type silicate asteroids we talked about earlier, and M-type metal-rich asteroids. Now, as their name suggests, C-type carbonaceous asteroids are carbon-rich. They dominate the asteroid belt's outer regions and comprise about 75% of all the asteroids in the belt. They're identifiable in that they have a redder hue than other asteroids in the belt, and also a very low albedo or reflectiveness. Their surface composition is similar to carbonaceous chondrite meteorites. Chemically, their spectra match the primordial composition of the early solar system, with only the lighter elements and volatiles removed. S-type silicate-rich asteroids are more common towards the inner region of the asteroid belt, within about 2.5 astronomical units from the Sun. An astronomical unit is the average distance between the Earth and the Sun, about 150 million kilometres or 8.3 light minutes. The spectra of S-type silicate-rich asteroid surfaces reveal the presence of silicates and some metals, but no significant carbonaceous compounds. Now, this indicates that their materials have been significantly modified from their primordial composition, probably through melting and reformation. They're easily identified because they have a very high albedo or reflectivity, and they form about 17% of the total asteroid population in the main belt. M-type metal-rich asteroids form about 10% of the total population. Their spectra resemble that of iron-nickel. Some are believed to have formed from the metallic cores of differentiated progenitor bodies that were disrupted through collisions. The number and distribution of M-type asteroids peaks at a semi-major axis of around 2.7 astronomical units. It's still not clear whether all M-type asteroids are compositionally similar, or whether it's simply a label given to varying types of asteroids which don't neatly fit into the main C and S classes. One mystery of the main asteroid belt is the relative rarity of V-type or basaltic asteroids. Theories of asteroid formation predict that objects the size of Vesta or larger should form crusts and mantles, which would be composed of mainly basaltic rock, resulting in more than half of all asteroids being composed either of basalt or olivine. Observations, however, suggest that 99% of the predicted basaltic materials are missing. Until 2001, most basaltic bodies discovered in the main asteroid belt were believed to have originated from the asteroid Vesta, hence the use of V for their classification. However, the discovery of several asteroids with slightly different chemical compositions from that of other basaltic asteroids suggests a range of different origins. While we often think of the main asteroid belt as being quite massive in terms of the total number of asteroids contained there, it's actually quite small compared to the millions upon millions of trans-Neptunian objects, asteroids, comets and icy debris orbiting beyond the orbit of Neptune in the outer solar system. What all this shows is that understanding the evolutionary history of asteroids and the main asteroid belt itself is far more complicated, as Jonathan Alley, the editor of Australian Sky and Telescope magazine, explains.
G'day, Stuart. In our March issue, our cover story is all about the asteroid belt, where it came from, what it's made of, and what it can tell us about how planets such as the Earth and the other rocky planets might have formed. The asteroid belt, if you don't know, is a loose collection of hundreds of thousands of bodies, big and small, everything from the size of a rock you could hold in your hand up to almost planet size. And they mostly orbit the Sun roughly halfway between the orbits of Mars and Jupiter, so a fair way out. The four biggest of the asteroids make up 55% of the total mass of all the asteroids. But that total mass itself is not really huge. All of the asteroids put together would only have about 5% of the mass of the Moon.
A lot of people say that, the asteroids would have formed the planet, but no, there was never enough material there to form a full-size planet.
There's not. And it's basically, I sometimes describe it as the builder's rubble left over from the beginning of the solar system. It's the sort of leftover bits that sort of just no one wanted. And they're just orbiting in a nice sort of place in between two planets. And look, not all asteroids are in that asteroid belt, but most of them are. And the other thing too, let's clear this up right at the beginning. And people will have seen movies like Star Wars, whatever, where
zipping between the asteroids, swooping in,
zooming through, whatever, and dodging whatever.
Behind an asteroid. You're going to tell me that's not real?
It's not real, and that's real. I'm trying to remember now the figure I saw, the average distance between asteroids. I think it's something like 10 million kilometres. It's certainly in the millions. They are very far apart, even though there's thousands and thousands and thousands of them. They're small, and space is big. So they are a long way apart. You could just, and in fact, I mean, back in the 70s, of course, when NASA sent some of the first deep space probes off, the Voyagers and the Pioneers, they had to go through, quote, the asteroid belt, unquote, and everyone kept their fingers crossed that they'd sail straight through. But they were pretty much certain they would sail straight through because it's just empty space, basically, with some rocks here and there, all just happen to orbit around the one path around the Sun. So yeah, it's not like it is in the movies at all, but nonetheless, it's still a pretty fascinating place because the interesting thing about the asteroids is that they are thought to remain mostly unchanged from when they formed billions of years ago, most of them. And so they can be considered time capsules, right? They're sort of frozen in time from the early years of the solar system. So they give us a glimpse into the solar system's past, which is why NASA and the Japanese Space Agency had sent spacecraft out to asteroids, and they've now brought some bits back, and there have been flybys of asteroids and orbits of asteroids, that kind of stuff. So scientists are really interested in studying these things because they are sort of time capsules. So they're handy for figuring out some of the characteristics of the material that went into making the rocky planets, such as Earth and Mars and Venus and Mercury, and maybe the cores of the other planets if they've got some rock in them as well. So in the magazine, we take a look at some of the hypotheses about how the asteroid belt formed, because no one's quite sure just yet, and when it formed, and what scientists are planning to do to conduct further studies of it.
So neatly straddles the snow line in the solar system, beyond which icy bodies form, and on the sun side of which all volatiles are evaporated away.
Yeah, exactly. It's like the snow line on a mountain where you get certain sort of vegetation up to a certain elevation, and all of a sudden you reach the point where the snow gets down to, and things change a little bit. So the vegetation might be different, even the terrain or the types of rocks or whatever could be different because it's getting different sort of weathering up at those elevations. So yeah, you're quite right. Volatiles, of course, being ices and things that will evaporate easily or sublime easily. Sublime is where it goes directly from an ice to a gas if it's heated up, rather than going through the liquid phase in the middle. So yeah, look, the asteroid place is fascinating for all sorts of reasons and largely unknown. These tiny rocks are a long way away from us, so for most of scientific history, all we've been able to do is just see them as tiny little dots of light in the sky. Then in more recent times, you've been able to get like spectroscopes and analyse the light coming from them and work out what they're made of. But only in the space age you've been able to get up close. And only probably, I'm guessing probably only about a dozen times, roughly speaking, since the 1980s or so, have they been able to get up close to asteroids. So there's still plenty to learn.
And we've only ever had one mission that really carefully explored them. We've had some missions that have gone through that area, but really it's only been the one NASA mission that's actually hung around and studied that area.
Yeah, the Dawn mission. Well, of course, that was its whole purpose, to go to Vesta and Ceres, which are the two largest of the asteroids. And Ceres being so big, of course, that it had enough of its own gravity to pull it into a round shape, which is why they call it a dwarf planet. planet. It's an asteroid, it's a minor planet, and it is a dwarf planet. It's all sorts of things at once.
That's Jonathan Nally, the editor of Australian Sky and Telescope magazine. And don't forget, if you're having trouble getting your copy of Australian Sky and Telescope magazine from your usual retailer because of the current lockdown and travel restrictions, you can always get a print or digital subscription and have the magazine delivered directly to your letterbox or inbox. Subscribing's easy. Just go to skyandtelescope.com.au. That's skyandtelescope.com.au, and you'll never be left in the dark again. And this is SpaceTime. Still to come, SpaceX successfully launches its 20th Starlink mission. And later in the science report, a new study shows that people diagnosed with ADHD in childhood are more likely to develop a psychotic disorder in later life. All that and more still to come on SpaceTime. SpaceX has successfully launched its 20th Starlink mission, carrying another 60 of the telecommunications satellites into orbit. The flight aboard a Falcon 9 rocket from Space Launch Complex 39A at the Kennedy Space Center brings the Starlink broadband constellation to over 1,200 satellites now in orbit. Following the mission, the Falcon 9's first stage booster successfully returned to Earth, landing on the drone ship Of Course I Still Love You, which had been pre-positioned downrange in the North Atlantic Ocean.
Falcon 9, Starlink, LD's go for launch.
And there's the final go for launch. Let's listen in to terminal count.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition.
Vehicle is pitching downrange.
Stage 1 chamber pressure is nominal.
T plus 40 seconds into flight. It is dark, but we can definitely hear Falcon 9. We have successfully lifted off from Pad 39A at Kennedy Space Center, carrying our stack of Starlink satellites into orbit. Right now, we're currently throttling down the engines in preparation for max Q. That is the period of maximum aerodynamic pressure, where we'll experience the largest structural load on the vehicle during ascent. So slowing the vehicle down helps during this period.
Max Q.
And there is the call out for max Q. We've just passed the period of maximum aerodynamic pressure on Falcon 9. In about a minute, we have 3 events happening back to back. First up is main engine cutoff, also known as MECO. This is where all 9 Merlin engines on the first stage will shut off to slow the vehicle down in preparation for the second event, which is stage separation. During stage separation, the first and second stage will separate from one another, with the first stage starting to make its way back to Earth for a landing attempt on our drone ship, while the second stage continues its journey with the third event, Second Engine Start 1, also known as SES-1. During Second Engine Start 1, this is where we'll light the Merlin vacuum engine on the second stage and propel the second stage along with the Starlink satellites into orbit.
MECO.
Stage separation confirmed.
INVAC ignition.
First stage separated from the second stage, making its way back to Earth, and we have a beautiful startup of the Merlin vacuum engine on the second stage. Coming up in a few seconds here is fairing deploy.
Fairing separation confirmed.
And off goes the fairing halves, exposing the batch of Starlink satellites on top of the second stage. As a reminder, we will be attempting to recover the fairing halves today with our recovery ships Go Searcher and Go Navigator.
Stage 1 is going to execute 2 burns in order to make its way back down to Earth. The first is the entry burn, where 3 of the M1D engines will reignite, and this will help slow the stage down as it re-enters the upper part of the Earth's atmosphere. The second burn is the landing burn. Now, this is a single engine burn that will bring the vehicle speed down rapidly in order to land on our drone ship, Of Course I Still Love You.
Acquisition of signal, Bermuda.
And again, our second stage is carrying our 60 Starlink satellites to LEO, or low Earth orbit. That's about 550 kilometers above the surface of the Earth. For reference, most satellites are actually in GEO, or geostationary orbit, which is over 1,000 kilometers above the surface of the Earth. And the reason that we have our Starlink satellites in this lower orbit is that it reduces the round-trip time that it takes for data to travel between the user and the satellite, reducing what is known as latency and improving performance in activities like video calls and online gaming. The first stage, it is coasting down, getting ready for the start of entry burn in about 40 seconds here. It is coasting using its 4 hypersonic grid fins and the occasional burst of nitrogen gas from its attitude control system. Getting ready for its entry burn in 10 seconds here, and then our second stage is
safed.
Looking good with our Starlink satellites.
Stage 1, entry burn startup.
You heard the call out for stage 1 entry burn startup.
Stage 1, entry burn shutdown.
We've had confirmation of a successful stage 1 entry burn. Second stage continues to look good.
Stage 1, landing burn startup.
You heard the call out for our start of landing burn. This will be about 20 seconds.
Stage 1, landing leg deploy.
Stage 2, FTS is safed.
Second stage is still looking good. We did just have confirmation of our successful stage 1 landing. Just had a call out for SECO 1, in fact, for our second stage, and a confirmation for a good orbit.
That marked the 75th successful retrieval of an orbital-class rocket and the 8th retrieval for this particular booster. SpaceX has designed the Block 5 version of its Falcon 9 first-stage booster to be reused at least 10 times. This is SpaceTime.
Level up your listening with Bose Quiet Comfort Ultra earbuds and headphones with immersive sound and world-class noise cancellation for a not-so-silent night. Visit Bose.com/Spotify to shop sound that's more than a present.
And time now to take a brief look at some of the other stories making news in science this week with a science report. A new study analysing data from 12 previous studies looking at some 1.85 million participants has found that people who were diagnosed with ADHD in childhood were more likely to develop psychotic disorders in later life. Although this type of study can't show that having ADHD actually causes an increased risk of psychotic disorder, the researchers say children with ADHD should be followed up beyond the age of 18. The findings, reported in the Journal of the American Medical Association, recommends further studies to investigate how these disorders could be biologically linked and whether early intervention for ADHD might reduce the risk of subsequent psychotic disorders. Microsoft has issued a warning that a Chinese government-sponsored hacking group is exploiting security flaws in its Exchange email services to steal data from businesses. The hacking group, named Hafnium, has a history of targeting infectious disease researchers, law firms, universities, think tanks, and NGOs. The attacks focus on stealing emails and infecting computer servers with tools that allow hackers to take control remotely. Last year, Beijing was found to be behind numerous cyber attacks targeting coronavirus research. At least 30,000 US organizations, including local governments, are currently being hacked by an unusually aggressive Chinese cyber espionage campaign. It comes as the Chinese government is warning its military to be prepared to go to war at short notice. Crippling computer systems could be part of that campaign. Paleontologists have uncovered the fossilized remains of a 20-meter-long titanosaur dinosaur in Argentina. Scientists say the discovery, dating back some 140 million years to the beginning of the Cretaceous period, may represent the oldest titanosaur ever found. Titanosaurs are a type of sauropod dinosaur and include the biggest living creatures ever to walk on the Earth. And the new discovery means titanosaurs survived much longer than previously thought, from the beginning of the Cretaceous right through to the end of the age of dinosaurs 66 million years ago. And just in case you've forgotten, let me again remind you that sauropods are those herbivorous dinosaurs that look like Fred Flintstone's pet Dino, with elephant-like bodies and legs, and a long neck and small head at one end and an equally long tail at the other. A new study claims night owls may be twice as likely as early birds to underperform at work. Around 10% of males and 12% of females are night owls. The findings, reported in the Journal of Occupational and Environmental Medicine, also suggest that night owls run the heightened risk of early retirement due to disability. The authors found that night people tend to accrue a sleep debt and have to catch up on the weekends. On the other hand, morning people tend to go to bed early enough to get the recommended amount of sleep. The authors say around 1 in 4 night owls reportedly underperformed at work at age 46. That's significantly higher than the early birds. Of course, if you are a night owl, you could just get a job that lets you work in the evenings, in which case the night owl outperforms everyone else. Pity so many managers aren't smart enough to have worked that out by now. The CIA has declassified a 1991 document showing that American spies had wrongly believed that the Soviet Union had successfully undertaken experiments in extrasensory perception and could transmit thoughts, gain information, and even move objects using only the mind. The document details bizarre experiments in Siberia, apparently undertaken during the mid to late 1980s. Volunteers would sit in the middle of a room, positioned between 2 concave mirrors, while the scientists tried from afar to transmit psychic energy to the subject. In another experiment, volunteers attempted to use telepathy to transmit images of geometric shapes, such as circles and squares, to each other. The Soviet Union's fascination with ESP stretches back to at least the 1950s. Tim Mendham from Australian Skeptics says the Soviet Union wasn't alone. The CIA apparently studied mind reading, remote viewing, telekinesis and other areas of parapsychology for many decades, but with no more success than their Russian counterparts.
I've got books on Russian ESP experiments. There was a date for about 20, 30 years ago. But this is ESP is, of course, extrasensory perception, as a term that was coined by a parapsychology researcher named J.B. Ryan, way back when in the 30s and 40s, who thought that psychic powers, as we might refer to them as, existed among certain people and wanted to test them. And the story was the Russians were following suit and they were testing people, especially people supposedly with supposed telekinetic powers. They could move things. And they did a lot of experiments. You know, the CIA and probably the American military did tests as well.
Where they could see things in another country without the use of cameras.
And the idea was also you could set off bombs in other areas. Like, there were suggestions that the nuclear arsenals could be exploded by a psychic. But this thing about the Russians is basically just some old files that have been released that, was sort of declassified and normal sort of released to the public. There's nothing new and nothing unknown that, people have known about these sort of tests in Russia for ever since they were happening, really. The tests that were done in Russia and the tests that were done in the US with the CIA and the military, you can read a lot about them in a book called The Men Who Stare at Goats. So that's quite a good book that actually sort of looks at a lot of these tests that were going on in America. So that's worth having a look at, but really nothing came of it. There was a lot of excitement when some particular psychic could move a matchbox or something like that, but magicians can do the same thing and they have demonstrated it. In fact, I know that James Randi did that to a group of researchers in America, I think it was military, who were getting very excited about someone who can move like a matchbox or something like that, and he just did it right in front of them and they looked embarrassed and all walked away, I think, because they were spending years on this thing, and then they just show a magician can do it just as well as these ESP subjects who are supposedly real, but who I would dare say were fakes all along, who were basically tricking the researchers, which is not that hard to do. It's called sleight of hand as much as saying it might be sleight of breath, but all those things. I mean, there was a famous fellow in America who could make pages turn, and it was so patently obvious that he was blowing on them until James Randi again stuck a sheet of perspex between him and the paper and said, now blow, now turn the pages.
And he couldn't. Again.
But it's as easy as that. But the scientists, of course, aren't used to subjects cheating. Mice in laboratory tests don't cheat, but people do. And that's the parapsychology tests that have been going on really since the late 1800s.
I guess a lot of that was also promoted by the Second World War and the supernatural beliefs of Hitler and his mob. The SS.
Yeah, they were very much into the paranormal. They were sort of, in fact, to the state where the other countries were taking advantage of it. I mean, they knew about it, and they were taking advantage of it. There was one case, I think, of a British plane dropping leaflets with phony Nostradamus predictions. They would upset the Germans, sort of say that you're going to lose. There was a lot of strange things that Hitler, and I think Goebbels too, definitely believed in a lot of strange areas, to the extent that theories about sort of sending Nazis down to Antarctica in underground bunkers down there or something, that they're still there.
And on the moon, don't forget they're on the moon too.
On the moon too, okay, but on the other side of the moon, so we can't see it.
You don't watch the History Channel enough. It's all aliens.
Yeah, aliens everywhere. But so I mean, Russian ESP, American ESP, the very fact that nothing has come of it, there's been no sort of use of this technology or skills, indicates that was probably nothing there in the first place.
That's Tim Mendham from Australian Skeptics. that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.
Level up your listening with Bose Quiet Comfort Ultra earbuds and headphones with immersive sound and world-class noise cancellation for a not-so-silent night. Visit Bose.com/Spotify to shop sound that's more than a present.
Hello, Saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.